Inscribed angles. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. Before we work through inscribed angles, we should recall central angles. Consider the circle given below. Central angles are angles with the vertex located at the center of the circle. The angle AOB is a central angle. The arc AB subtends the angle AOB. The arc AB is called the intercepted arc of the angle AOB. The term intercepted arc refers to an arc cut off or lying between the sides of the specified angle. The measure of the central angle is the same as the measure of the arc it intercepts. For example, if the measure of the central angle is 50 degrees, then the measure of the intercepted arc is also 50 degrees. Consider the circle given below. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of a circle. Pay attention. The angle ACB, or theta angle, is the inscribed angle. And the arc AB is the intercepted arc. The Inscribed Angle Theorem states that the measure of an inscribed angle is half the measure of the intercepted arc, or theta equals arc AB divided by 2. If a central angle and an inscribed angle intercept the same arc, then the inscribed angle is half the central angle. Now we must prove this theorem. To prove it, we must consider three separate cases. In the first case, the center of the circle is on a side of the inscribed angle. In other words, the diameter lies along one ray of the inscribed angle. Let's draw a triangle AOC. The segments AO and CO are both radii, so they have the same length. This means that the triangle AOC is isosceles, which also means that its base angles are congruent. The alpha angle is exterior angle, and we know that an exterior angle of a triangle is equal to the sum of the opposite interior angles. So the theta angle equals alpha divided by 2, as required. We have completed our proof for the first case. In the second case, the center of the circle is inside the inscribed angle. The angle ACB is the inscribed angle, and the arc AB is the intercepted arc. The angle AOB is the central angle that subtends the same arc as the inscribed angle. Using the diameter, we form a pair of isosceles triangles that share a leg. The two base angles of an isosceles triangle are equal, so we can label angles on the figure as follows. We know that an exterior angle of a triangle is equal to the sum of the opposite interior angles. The central angle AOB is the sum of these two exterior angles. The angle ACB equals z plus y. The angle AOB equals 2z plus 2y. The angle AOB is 2 times the angle ACB. Therefore, the angle ACB is the angle AOB divided by 2, as required. We have completed our proof for the Second case. In the third case, the center of the circle is outside the inscribed angle. To prove the third case, we will draw an auxiliary line outside the circle. We draw the diameter CD. The triangle BOC is isosceles, so we can label angles on the figure as follows. The exterior angle of the triangle BOC is equal to the sum of the opposite interior angles. The angle AOB is the central angle that subtends the same arc as the inscribed angle. The triangle AOC is isosceles, so we can label angles on the figure as follows. The exterior angle of the triangle AOC is equal to the sum of the opposite interior angles. So the angle AOD is 2 theta plus 2 alpha. We can see that the angle AOB must be 2 theta. The measure of the central angle is the same as the measure of the arc it intercepts. So the arc AB is 2 theta. The inscribed angle theta is the measure of the arc AB divided by 2, as required. We have completed our proof for this third case. Find, given reasons, the measure of the blue arc or angle. 32 degrees is an inscribed angle, and the blue arc is the intercepted arc. We know that the inscribed angle is half of the intercepted arc. So the blue arc is 64 degrees. The intercepted arc is 110 degrees. And theta is the inscribed angle. The inscribed angle is half of the intercepted arc. So theta is 55 degrees. "42 degrees is an inscribed angle, and the blue arc is the intercepted arc. We know that the inscribed angle is half of the intercepted arc. So the blue arc is 84 degrees. Theta is the inscribed angle, and the blue arc is the intercepted arc. The inscribed angle is half of the intercepted arc. So the theta angle is 42 degrees. It's always true. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. The triangle AOB is isosceles, so the base angles are equal. The sum of the interior angles of any triangle is 180 degrees. Therefore, the angle AOB is 90 degrees. The angle AOB is the central angle, and the measure of the central angle is the same measure of the intercepted arc. So the arc AB is 90 degrees. Theta is the inscribed angle, and the inscribed angle is half of the intercepted arc. So the theta angle is 45 degrees. The angle CAD is the inscribed angle, and the arc CD is the intercepted arc. The angle CBD and the angle CAD intercept the same arc. Then the angles are congruent. An exterior angle of a triangle is the sum of the opposite interior angles. So 96 degrees is 54 plus theta. Theta is 42 degrees. Theta is the inscribed angle, and the arc AB is the intercepted arc. So the arc AB is 84 degrees.